Okay, so let's look at this chapter 1 of physics. Okay, so first of all, length and time. Okay, so length, how to measure length? You can use a rule or a ruler to measure the length for distances between 1 mm and 1 meter. So if you use ruler before, you should know the smallest part of the ruler is 1 mm. And then the ruler that we are talking about is the 1 meter ruler, not the ruler that you put in the pencil box. So it's the 1 meter ruler. Okay, so that's why they can measure from 1 mm to 1 meter. The SI unit for length is the meter. To find out the volume of regular object, use mathematical formula. So let's say, for example, if you have a regular object, for example a cube. If you have a cube, so you want to find the volume, you just use mathematical formula, length times width times height, for example, and then you can get the volume. If let's say you have a cylinder, we also use mathematical formula. Volume is pi r square h. Okay, so have to use mathematical formula for regular object. Okay. To find out volume of irregular object, put object into measuring cylinder with water. When object added, it displaces water, making water level rise. Measure this rise. This is the volume. So that means something like this. You put a measuring cylinder with water. Okay, with water. So let's say at the beginning the reading is 20 cm3. Then you put a regular object inside. Let's say you want to measure the volume of a stone. So you just add the stone inside. So you add the stone. Add a stone. The stone is of irregular shape. Okay, so you add, then the measuring cylinder show a volume of, together with the stone. Okay, so let's say it shows the volume of 35 cm3. So from here you just minus 35 minus 20, then you get 15. So 15 cm3 is the volume of the irregular object, which is the volume of the stone. Okay, so we just find the difference of the water level to find out the volume of the irregular object. Okay, now let's move on. The next one, micrometer screw gauge, used to measure very small distances. Okay, so determinations of the diameter d of a wire. This is the example. When we use micrometer screw gauge, example, you want to find out the diameter of a wire. So you put the wire here, then you turn the thimble to tighten up the space here, and then of course you will hear sounds like tug, like that. Okay? The ratchet will produce sounds showing that you already tighten up this part here to measure the wire. Okay, so you cannot keep turning the thimble until it has too much pressure on the wire. So the ratchet will control the pressure. When you hear the sound tap, that means the pressure is okay already, and then you can read the diameter of the wire by reading the main scale and the rotating scale. So how to read the main scale and rotating scale? Of course we have example. So we will come to it later. So we will discuss this also. So place the wire between the anvil and spindle end. So anvil is here, this part. Spindle end is here. So anvil is the part that cannot move one. Spindle is the part that can move. You can turn the thimble to move the spindle. So as indicated in the diagram, Rotate the timber until the wire is firmly held between the anvil and the spindle. The ratchet is provided to avoid excessive pressure on the wire. So that's why you will heard the sound tug like that. So showing that it is tightened at the proper pressure already. So it prevents the spindle from further movement, squashing the wire. So we don't want it to squash the wire too much. So to take a reading, first look at the main scale. Okay, let's see. Okay, so first you have to look at the main scale, which is this one. Okay, so I zoom in a bit. So basically how to read is, you need to know this is 0. Then this short line is basically 0.5. Okay, 0.5. Then this one is 1. Then this is 1.5. Then this is 2. Then this short line is 2.5. Okay, so when you see the last line over there on the main scale is 2.5, so that means we have to take this as 2.5 mm. 2.5 mm from the main scale. Okay, then you look at the rotating scale. Rotating scale is where you have to see the line that is horizontal with this line, or coincide with this line. That means the same line. Okay, the line that forming the same line with this main scale. Okay, this is the line. What value is this? You see this is 40, 45. This is 50, right? So you should expect this is 46. So this is 46. 46. So if you know that is 46, right? Then you put 46 like this. Okay, then you add up. That means 0.46, in other words, 2.96 mm. So that is the diameter of the wire. So you can see two parts. This is from the main scale. This is from the rotating scale. Then you add up, 2.96 mm is the diameter of the wire. Okay, so that is how we read. Okay, now let's continue. Okay, so first look at the main scale. I already discussed with you. This has a linear scale reading on it. The long lines are every millimeter. The shorter one denote half a millimeter in between. Like what I said, 0, the long line, 1 meter, then plus 1 meter again. So the short line is 0.5 millimeter. On the diagram, this reading is 2.5 mm. So this one we discussed already. Now look at the rotating scale that denotes 46 division. 46. Each division is 0.01 mm, so we have 0.46 mm from this scale. The diameter of the wire is the sum of this reading, 2.5 plus 0.46 equal to 2.96 mm. So that is how we read micrometer screw gauge. Okay, now let's continue. Next one. Time. Interval of time is measured using clocks like stopwatch. Okay, SI unit for time is the seconds. To find the amount of time it takes a pendulum to make a spin. Time of about 25 circles, and then divide by the same number as the number of circles. So what are they trying to say is, you try to imagine something like this. This is your pendulum. You make it oscillate. So when the pendulum oscillate, right? Let's say it starts from here lah. So it oscillates, move here, then come back here. That is considered one oscillation. One oscillation. You must start from this point, then you let it go back to the same point to count as one oscillation. You want to measure one oscillation. Normally, you can easily mix error. Okay, maybe you are thinking of something else and you forgot to press the stopwatch. Okay, you can easily make mistake. So that's why they say you let the pendulum to move 25 oscillation or 25 cycles, 25 circles. Okay, they say circles. So that means 25 oscillation. That means 1, 2, 3, and so on until 25. Then you take the time. Taking the time of 25 circles is better because later you can average to by dividing with 25. No? You take the time then divide by 25 to get the period. Period means the time for one round. Okay, so that's what they said. Okay, now let's continue. Okay, we look at this part then. Speed, velocity, and acceleration. So speed, the distance an object move in a time frame. It is measured in meter per second or kilometer per hour. Formula, speed equal to distance over time. Speed is a scalar quantity. So scalar quantity means quantity without direction. It has only the magnitude. Okay, so now we see the speed time graph. So the first graph, you can see the y-axis is speed. V means speed. The x-axis is time. Speed time. So if you have a straight line coming out from origin, so what happens here is the particle or the object is accelerating. Okay. Why accelerating? Because the gradient represents the acceleration. So you see this graph has gradient. If you think of the gradient formula, which is gradient equal to y2 minus y1 over x2 minus x1. So you can count the gradient. The gradient has value. If the gradient has value, that means it is accelerating. If you look at this graph, the gradient will be negative. If the gradient is negative, that means it is deceleration. Okay, so the difference between acceleration and deceleration is acceleration is where the object is moving faster and faster. Deceleration is where the object is moving slower and slower. Okay. Okay. Now, just now we talked about acceleration, which means the object is getting faster and faster. Deceleration is where the object is getting slower and slower. And now you look at the third graph, when it is just a horizontal line. Imagine when you count gradient, right? You will get gradient equal to 0. Gradient equal to 0 means acceleration is 0. And acceleration is 0 means it is not getting faster and faster. It is moving at constant speed, same speed. And if the line is here, that means the speed is 0. So in other words, it is not moving. It is stationary. Area under the line or area under the graph equal to the distance traveled. Okay, let's say I give you one example. Okay, let's say you have a graph like this, speed versus time. So you have this. Let's say here is 3, here is 5, and let's say here is 4. So if you want to count the acceleration we use A. So we just take 2 points.
Trapezium.
Yes, trapezium. you want to find the area, we use trapezium. So let's say I find the gradient first. So we use gradient formula. 5 minus 3, 4 minus 0, 2 over 4 equal to 0.5. So you count the gradient, then you get the acceleration, 0.5. Okay, so if you go and count the area, which is the trapezium, so the trapezium, the area represents the distance. Distance 1 over 2. Add up the parallel sides, 3 plus 5. Multiply with the width, get 4, and then you get 16. So that is the distance. Okay.
So the area on the graph, I mean the gradient is always the acceleration.
Yes. Yeah, but you have to remember one more thing also. This is for speed time graph. For speed time graph, the gradient is the acceleration. But if it's different kind of graph, like distance time graph, it's different. For distance time graph, the gradient is speed. It's speed. Yeah. Okay. So how we remember it? Of course, there is a way lah. You want to know what gradient represent, right? You just take this, divide by this. Speed divide by time. Speed divide by time, you should think of acceleration. Distance divide by time, you should think of speed. Okay, so it helps us to remember what the gradient represent by taking the y-axis divide by the x-axis. Then you can remember the gradient represent what. Okay, so now let's see the first graph here. If the graph is from origin, straight line from origin, imagine you go and count the gradient, right? You will get a value, a constant, you get a constant. So that means the speed is equal to that constant. So we call that constant speed. So if the line is going up, that means the object is moving forward. But if the graph is going down, that means the object is moving backwards. And if it is a curve, that means what happened is the object is accelerating. Okay, the object is accelerating. So imagine the gradient represent speed, right? So you imagine you draw the gradient. You have to measure the gradient of tangent. You can see the gradient. This one, the gradient is smaller. This one, the gradient is higher. Smaller gradient means the speed is smaller. Higher gradient means the speed is higher. So from here, we can see that from low speed to high speed, this is what we call accelerating. Okay, so if it is a horizontal line, then no change in distance. No change in distance means the object is not moving stationarily. Okay, so these are the graph. And okay, let's go through a little bit more. We see the next part. Distance. Calculating distance traveled with constant speed. So if there is no acceleration, right? So it's very easy. When there's no acceleration, when it's constant speed means no acceleration. So distance equal to speed multiplied with time. Okay, so of course we know this long time ago, right? That time we learned speed equal to distance divided by time. Okay, now we just rearrange the formula. Distance equal to speed multiplied with time. So this formula is true when there is no acceleration. If there is and acceleration, then you cannot use this formula anymore. You have to use different formula. So if there is an acceleration, distance equal to final speed plus initial speed over 2 multiplied with time. Okay, so of course normally we represent it by using this formula. Distance equal to u plus v over 2 multiplied with t. So this formula is used when there is an acceleration. So we use this formula. So u is initial speed, v is final speed, divided by 2 multiply with time. So u initial, final. So let's say one example. Okay, one example. Let's say you have a trolley move at 20 meter per second. After after 10 seconds, the speed become 35 meter per second. So from here you know this is increasing in speed, right? It's accelerating, right? Okay, so u is 20, v is 35, t is 10. So we count the distance. S equal to u plus v over 10, then over 2 multiply with 10. Okay, then you will get 55 times 10 over 2, so you get 275. This is the distance moved by the trolley. Okay, so finally you can see another formula here. Accelerations, final speed minus initial speed over time taken. So normally you will see this formula as A equal to V minus U.
I need to shut the door.
Okay. So you will see the formula is written in this form normally. A equal to V minus U over T. Okay, so let's say example again. This same example, I have U, I have V, I have T. I can count the acceleration. So the acceleration is A equal to V minus U over T. So you have 1.5 meter per second. 1.5 meter per second. -2. Okay, so that is the acceleration.
The first one is the speed.
Yeah,
I mean,
initial speed.
no, I mean the S equals to 20 plus 35 over 2, that is the speed.
When I use S, right, actually this is displacement. Displacement. Displacement.
So speed is also S, right?
Sometimes you will see speed is written as S, but the more formal symbol for speed is actually V. As you can see here, V. So even in here, you can see that also. Initial speed, U. Final speed, V. So speed and velocity, they use V.
So we can use S equals to bracket u plus v over 2 close bracket t
Okay.
when there is only acceleration.
Yes, correct. When there is no acceleration, then you use this formula.
So we can, I still don't understand the acceleration formula. Let's say, sir, we
Yeah.
still have acceleration. Can we use either s equals to u plus v over t over 2 times t, or a equals to b minus u bracket, divide by t? We can use either one, right?
Actually, no. It depends on what you want to find. We use this formula to find the displacement or the distance. We use this formula to find the acceleration. So depends on which one you want to find. If you want to find distance, you stick to this. If you want to find acceleration, then you stick to this. So yeah. Okay. So that's why you see when I use this formula, I get 275. 275 is the distance traveled by the particles or by the trolley. When I use this formula, I count, I get 1.5. 1.5 is actually the acceleration. Acceleration. Maybe you are wondering also, 1.5 meter per second per second. How to understand that? It's something like this. Imagine what is mean by 1.5. Okay. So imagine at t equal to 0, right? The speed is 20. As you can see, 20. Okay. So after 1 second, it increased by 1.5. It increased by 1.5 become 21.5. After another second, it increased by 1.5 again become 23. After one more second, it increased by 1.5 again become 24.5, and so on. It keep increasing 1.5 in speed. Okay, so then you should expect after 10 seconds, you see here, our case is 10 seconds, right? So after 10 seconds, it should have increased by 1.5 times 10, which is 15. So 1.5 times 10. So increase by 15 meter per second already. So 20 plus 15, so that is 35. Okay, so this step by steps working is just to let you see or imagine on what is acceleration. Okay, so 1.5, that means every 1 second the speed increased by 1.5 meter per second, something like that. Okay, yeah. Okay, now we have done acceleration. Okay, now let's see some past year questions. Okay, so let us look at page 23, question 2. Okay, so from this question, right, let us discuss. An object move at a constant speed for some time, then begin to accelerate. Which distant time graph shows this motion? Okay, so do you have any idea or not? Constant speed, how's the graph?
There's no acceleration.
No acceleration. Then after that, they accelerate. So which graph is correct?
Just give me a minute, sir.
Okay.
Is it C?
Yes, C is correct. If you still remember the graph just now, right? Constant speed is a straight line. Acceleration is a curve. Okay, so here is the straight line that show constant speed. Here is the curve that show acceleration. So C is the answer.
So
Yeah.
this is a distance time graph, right? So
Yeah, distance time graph. Oh,
why your
okay.
graph is
Not V, it's distance.
okay.
Yeah, okay, it's distance time graph. Okay, so for distance time graph, straight line from origin is constant speed. Curve is acceleration. So
Okay.
that's the answer. So that's why it is C.